Today I'd like to present a paper which is regarding air purifier technology trend. And for this paper, I made in this way. First the introduction, and the second numerical approach, and then analytical result, and I made some conclusions from this. And for the introduction, there are many. It's basically based on the series problems in atmosphere. Look at this. I summarize in this way. So due to the deterioration of air quality caused by environmental damage, by the actuation of high-level industrialization at home and abroad, measures against the fine dust are currently very serious. In China especially, environmental problems has become very serious due to the increase in vehicles and climate, inland area, or satellite urban development. This fine dust not only pose their own risk, but also health problems which serious affect health in situation. The demand for air cleaners are rapidly increased. Air purifier has been used primarily for public or medical facilities, but recently, as demand for household use has increased, various development has been conducted. In Korea, in past, it has been developed mainly as an air conditioning company, but now small and medium-sized enterprise also jump into this sector, and various products are being developed. Air purifiers are developed by separating them into mechanical, and electrostatic precipitators due to their structure, and the structure, the mechanical type can be divided into wet type using water, and the dry type using the oily HEPA filter. In addition, recently, multifunctional products has been released by providing an air cleaning function through an existing cooling and heating system. On the other hand, recently, the technology for blocking the outside air due to construction technology is advancing. And it's the development of complex air purifiers that moves gaseous substances, or VOC or CO2 generated by indoor, is in progress. In order to remove gaseous substance like this one, CO2 mainly, technology has been developed to incorporate activate carbon or catalytic technology. And it is an attempt to develop by introducing an electric discharge method using a plasma filter. On the other hand, the design technology for improving performance of air cleaners are being developed. And the detailed technology affecting performance improvement will be focused on the removal or efficiency of gaseous substances such as noise, dust collection efficiency, airflow, and the CO2, in order to improve the performance and energy efficiency of the ventilated air purifier through this study. An appropriate blow fan or an appropriate blower and inlet size was calculated. Let's summarize our focus on this research. In order to remove harmful CO2 generated from the indoor air, the purpose of this study was to understand the temperature and the pressure changes through computational flow analysis, focusing on the analysis intake or exhaust vents or internal structural air cleaners. This is kind of we try to understand the configuration for the air purifier like this. Okay. Basically, we are focused on these configurations. This is an outlet vent, and this is another this fan, and then the other side there is another fan for the exhaust flow. This is for the supply air from here is outlet from here and through this and move to the and then another CO2 inside. The CO2 is going through this way and then go outside. This is for the for numerical analysis. So we made some brief generation on this with this scheme. Mesh type is tetrahedral structures, and the number of meshes like this. And basically, we are focused on this exchanger. Let's look at some view. This is from the front view, and this is side view like this. There's something like this, and basically we are going inside and then through the heat exchanger and go outside and come back to the in this inside door, and then there some CO2 is moving through this ways and then take out. Okay, and then during this exchanger has some function take out the otherwise the inside temperature and the outside temperature there are some differences, so we can take out and then we can hold some temperature heat, and then we put this way and more heat here and go outside. Recirculate. This is for the velocity profile. Like this is for the supply flow field, like this, and also like this, and then go inside, and then move to the and then go like this. This is only for the supply flow. Let's look at another things in the look at here. This is for the velocity of exhaust flow field, and then this is like CO2 inside, and then we can take out and then outside, and then there's some flow, the heat exchange through this system. Okay. This is pressure distribution, so we're using both by using the damper, and then like this outside, and then like this, and then we can measure the pressure distribution on this, and then look at, and this is on the main fan, and then this is exhaust fan. Okay. This is the side view of the pressure distribution. And also, this is temperature distribution. You can say like this, and then as you see in this way, this is the temperature is very high, and which is represented in a red color, and then very hot, and then coming in come out this way, and then another flow, cool flow is coming inside, and there is something. Heat exchange coming up, and then we can pass to the so we can save the energy, heat energy. Okay. And then this is for various distributions. And then the whole thing like this. How gonna be? And so this is show the various distributions. Let's make some conclusion on this. First, air supply, air volumes represented as design variable were given in the condition of 0.18 cubic meter, which is called the 60 650 cmh, and the exhaust airflow is 0.15 cubic meter is corresponding 540 cmh. Conditions indoor air temperature is 20.9 degree, and outdoor temperature is 8.3 degree. There something has to be changed, exchanged. Look at the heat transfer relationship through the heat exchanger. The amount of heat emitted from the room to the atmosphere is about 13 degrees, and the heat sources obtained through the heat exchanger is about 7 degrees. And also, in the view of pressure distribution, the pressure when moving through the total heat exchanger was lower by about 0.3 kilopascal, and when the indoor air is exhausted, the pressure change when the passing through the total heat exchanger was about 0.2 kilopascal. This is because the supply fan's capacity is equivalent to the 80%. Like this is 65, 650, and this is it's just fan is smaller than the supply fan. Okay, that's why it's about 80%. It makes sense. Okay. Overall, it can be understood the temperature distribution and the pressure distribution and the various distribution are properly interpreted. So, and this is kind of numerical approach to understand the air purifier. So my presentation is over. So thank you for listening. Thank you. Yes, sir.